which is just sort of checking in on how you all are doing. So does anyone have any questions, comments, or concerns to raise with the class? All right, well, it's a light load today, not many of you, and since it's a discussion day, let's just dive right in and see if we can't go home early. So we're discussing Bergstrom West, Chapter 5 today, Numbers and Nonsense. So who wants to start us off with a quick summary of what this chapter is all about? Sita.
It goes through some examples, as this book does, but it discusses the kind of invalidity of number data if it's presented in an incorrect context, or how it can kind of be skewed differently.
Yeah, excellent point. So this book, the chapter is called Numbers and Nonsense, and it starts out with, I think, a really compelling and really motivating question, which is, are numbers objective? So what do you guys think? Are numbers objective? And if so, why or why not? Beth, what do you think?
I was reminded a lot about selection bias during reading it, so I feel like they could be objective to a certain point.
Yeah, and excellent point. This chapter really lays the groundwork for a lot of the forms of bias we've been talking about. Not just selection bias, but small sample bias and other forms of bias as well. Chloe, I see a hand.
If numbers can be objective, if the person collecting them tries to be as unbiased as possible, because they take samples from a number of people on some subject, they can be objective. They can say, yes, this many people like this many people like that. But so choosing on selection bias, or if the person knows that this amount of people are going to, hold the team to one or the other, or the people collecting those numbers.
Right, excellent point. And numbers are objective to a certain extent. And the examples which you mentioned, the book mentions as well, like numbers are fairly objective when it comes to things like counting. It's reasonable to get an accurate count. Right now we can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 students are in the class right now. We accurately counted the number of students that are sitting in this class right now. That is an objective, accurate measure. We have an objective, accurate measure of the number of students that are registered for this class, 40. We can get that on my.sbc.edu. So we have 15 students sitting in class, 40 students that are supposed to be sitting in class. But there's a lot of ways in which numbers can't be objective. Those numbers I just cited leave out the fact that some of you have remote accommodations. So maybe it's not supposed to be 40 students are sitting in this class. Maybe it's supposed to be something more like 35 students are sitting in this class, while some other number of students are, right? So numbers might not be objective. Chloe mentioned sampling bias. How might sampling bias come into play when we're counting, right? Sampling, if I'm sampling the students who are sitting in class, obviously none of you, by construct, are going to have remote accommodations. So if we use that to extrapolate, who here in this class has remote accommodations for Core 170? None of you are going to raise your hand because you don't. You're sitting in class right now. We're not going to get an accurate count of how many people have accommodations. What are some other ways that numbers might not be objective? Certainly they can be, particularly when it comes to counting, but there are other ways we react to and deal with numbers on a daily basis, and those ways might not be as objective. So what are some of the ways that subjectivity comes into play with numbers? Peyton, is that a hand?
People can select another type of view what they want you to hear.
Absolutely right. For anyone who didn't hear Peyton, what she said was, numbers can come into play in an objective or a subjective sense, in a couple different ways. One way is through marketing, right? When people are presenting you with numbers, usually the goal is to convince you of something. Because we have this ex-ante belief that numbers were objective. The word they use in the book is the primacy of numbers, right? They are the one above all. We can always rely on numbers. Words are what's going to lead us astray. But because of that, when people are citing us numbers, when people are quoting numbers to us, chances are they're trying to sell us something. 95% less fat. Less fat than what? 99.9% caffeine free. Relative to what? What's the caffeine baseline? Caffeine free by weight? Most of what you're drinking, out of anything, is water. Water is caffeine free, naturally. There are some other ways that numbers might be subjective. Certainly there's the sort of outright bullshit where people are trying to convince us of something. What are the other ways? We've seen a few in this class. Yeah, Kaya. Yeah, excellent point. So definitely there's the sample, but you raise an interesting point, which is not just the sample, but the sample statistics you're citing. So mean is a simple average. You add up all the values, you divide it by the number of values in that set. We can take an average age of the people in this room, a mean age of the people in this room. Why might mean age not be a meaningful measure for the people in this room? Yeah, right. Excellent point, because typically college students tend to be younger people. Let's say what you said in reverse. Cheryl and I are going to throw off the average age of the people in this room. We're much older than you, unfortunately. Young at heart, but much, much older than you. So if we took a simple arithmetic average of the age of everyone in this room, it might not be an accurate reflection, I should say, of the ages of people in core 170. Median is a different type of average. Median is the measure of the halfway point. By definition, half of you are going to be above the median, and half of you are going to be below the median. If we took the median ages of people in this room, the median age, the fact that Cheryl and I are on this far old end of the spectrum is just going to get lopped off. We're just two of the people that are above the median age in this room. Kaya, excellent point about not just what you're citing and not just the samples you're citing, but the sample statistics you're citing can be one way in which numbers might be more subjective than they appear at first blush. The authors mention another way that numbers might be subjective, and that's modeling. So last week, when we were studying regression analysis, we introduced a few models where we said your grade in the class might be some combination of the student-to-teacher ratio plus your innate ability plus how lazy or motivated you are plus how much you spent studying. And we said, if, and that's a big if this is the true data-generating process, then we can start to draw some cause and effect relationships from student-to-teacher ratio to course grade. But the problem is, we don't know that if. What we did was choose to model. We chose a model that was up on the board a week ago, where we said John Gregory Brown is 4 lazy. The book gets at another reason why this might be bullshit. Let's talk about that in a few minutes. If John Gregory Brown is 4 units of lazy, what's that going to do to his test score? But this is just a modeling assumption we made, and it might, because it's just an assumption we made, be bullshit. Whether or not we have malicious intent, mind you. We can be genuinely interested in the relationship between student-teacher ratio and test grade. But because once those numbers, once those data, once that information comes to our desk, we have to model it in some way. We have to assume things, and for the most part, we want to make our assumptions simple. We want simplifying assumptions. We might encounter bullshit and subjectivity in our modeling. So Sita, you got us started by saying that one of the things this chapter does is ask the question of whether or not numbers are objective or subjective. What are some other things this chapter tries to accomplish? Or maybe what's something more in depth that this chapter does? Yeah, Sita.
Maybe not more depth, but it also talks a lot about how numbers are presented can affect their impact with the amount of alcohol lost and how you can measure that in lots of different ways.
Excellent point. So on top of addressing this first question of whether or not we're dealing with an objective issue, we talk about some of the ways these numbers are presented to us. So, putting the question of subjectivity aside, even in an objective sense, the manner in which numbers are presented to us might present some problems. What were some of those problems? Sita already hinted at a few, but what were some of the problems about number presentation? So putting aside questions of sample selection bias, or outright bullshit, or modeling assumptions. What problems might be presented to us just based on number choice? And by number choice, I mean the way numbers are presented. So Kaya, you mentioned the difference between mean and median. That is one way in which we might be led astray with numbers. What are some others? Sita, you already mentioned one. Do you want to dive in a little bit?
Sure. There's the example about the angel share of alcohol disappearing or evaporating while it's sitting in this nice barrel. And that you could measure that in a ton of different units of measurement. And so, which one is the best to give to a population of people that they can understand more easily?
Yeah. Choice of units might present us with an opportunity to be bullshitted. Let's think about choice of units. And we can use that example of alcohol that gets denatured or evaporates. There's percentage. What percent of the barrel? Riley, you had a hand. Right? Right? So there's percentage versus unit. There's unit transformations. So what's the difference between a centimeter and an inch? What else is there? What are some of the ways in which alcohol can be presented to us? By unit. Or by number, let's say. Percentage lost, milliliter. Yeah, Lyra. Potency, right? So we can talk about proof. We can talk about market value. We can talk about volume, not just in terms of how much is in the bottle, but volume in terms of how much does the factory produce, how much does the county produce, how much does the country produce. All these different ways of talking about what is essentially the same number can lead us astray in terms of bullshit. Sita, you mentioned percentages, and percentage is really interesting as a concept of bullshit, as a concept of subjectivity, let's say. What's one of the benefits of using percentages? Yeah, Chloe.
Sometimes it can give you a more detailed understanding of
Right, so sometimes percentages can ameliorate some of the bullshit. Saying 1 milliliter doesn't tell me much. But saying 1 milliliter as a percentage of how much alcohol is evaporated can tell me a great deal. But percentages also might exacerbate bullshit, might make it worse. What are some ways in which percentages can make it worse? Yeah, Sita.
You can select your percentage to be about anything. So depending on what you pick, you can skew numbers.
Right, for anyone who didn't hear, you can select your percentages, and there's a couple different ways. One is percentage, and really percent changes are dependent on the starting point. And what starting point we pick might have important meaning. The book, sort of presciently so, uses the example of how much value Bitcoin is gaining or losing. Bitcoin is very volatile. So if we talk about the percent Bitcoin has gained since December 1st, that's going to be very different than if we talk about how much higher or lower Bitcoin was valued relative to now. And it feels instinctively like those numbers should be the same. Percent gained since December 1st or percent lower relative to now. But they're not. They're not the same number because percentages, and percent changes in particular, are dependent on starting point. That's not the only way in which percentages and percent changes can lead us astray, though. Because when we're dealing with percent changes, we're dealing with fraction changing. Now, everyone knows their first grade math. A fraction has two parts, the top and the bottom, the numerator and the denominator. But when we look at changes that are occurring in society overall, oftentimes the top and the bottom change together, which is going to have important differences, important implications for how we interpret a percent changing. So the example the book gave is Scott Walker, former governor of Wisconsin, said that his state was responsible for 50% of the decrease in the unemployment rate. Which seems quite silly, because Wisconsin certainly didn't have 50% of the unemployed people in the country. But the top and bottom of that fraction were changing at the same time. The unemployment rate was changing. How many unemployed people were in the country overall was changing at the same time the unemployment rate was changing in Wisconsin. So you're going to see these misleading fractions leading to misleading percent changes. The fact that this thing that seems objective, numbers, can actually be quite subjective or quite full of bullshit, hints at something we've sort of been talking about throughout the semester. Perverse incentives. Remember, an incentive is just something that motivates behavior. And we might have some ideas of how we want behavior to act. We might want people to tell the truth. We might people to be good, whatever that means to you. But if we can lie with numbers, we might have incentive to change our behavior in a way that's inconsistent with societal goals, broadly defined. So who can think of something perverse that we saw in this chapter? Or who can think of a perverse incentive in your own life, maybe? Yeah, Elizabeth.
I mean, because it's pretty much everywhere, you can make money regardless of the moral choices that it causes.
Absolutely. The incentive to make money regardless of moral choices. So Sweetbriar does this a lot. Sweetbriar markets on what a great COVID response we've had. I don't know about you guys, but I check the Sweetbriar COVID dashboard every day. And it doesn't add up to me. We have, right now on the Sweetbriar COVID dashboard, no people listed in quarantine. That doesn't seem right based on what we all know about our friends and classmates. For a while, we were listing no people on campus having COVID, not because we don't have anyone in the community that doesn't have COVID, but because we sent them off campus. That's a perverse incentive. It might be objectively truthful with a number, no one on campus has COVID, but it's not true in the sense of what we take the meaning to be. What are some other ways people have engaged in perverse incentive behavior with numbers? So the book mentions this concept of teaching to the test. Are you guys familiar with it? When you guys were in high school, much of your high school's funding was determined on how well you all did on standardized testing. Standardized testing has noble goals. We want to know how Beth's school is doing relative to Riley's school, is doing relative to Kaya's school. If there's some way that we can have some objective, numbers seem very objective, if there's some way we can have some objective baseline measure, then we can determine how schools are doing and which schools need appropriate funds. It seems very noble. What happens in real life? Or I should say, in the naturally occurring world. Elizabeth.
You have teachers prioritizing standardized test scores over student learning experience.
Yeah, what happens is because we place a bunch of weight, a bunch of emphasis on these standardized testing, you have teachers who their bonus is dependent on how well you do on your standardized test. They're going to teach the test. They're not teaching you critical thinking skills. They're not teaching you rhetoric or logic or reasoning. They're teaching you when you have 4 questions on a multiple choice test, try and rule out one question because then you can have a much higher likelihood of getting that question right. There's some evidence that we also see outright cheating, where teachers will go in with their eraser and change your marks. Colleges do this as well, not so much changing your marks, but if the way SweetFire falls in the rankings is dependent on things like SAT score, ACT score, we might ask an accepted student to retake the SAT with the promise of a bonus for a higher grade. We'll then report to US News, look at our average incoming SAT score. The book lumps this all in to what's known as Goodhart's Law. Goodhart's Law is the idea that when something becomes a measure, test score, BMI, whatever, it ceases to be informative because people aim to reach that measure. I saw something on Twitter the other day. Guy, he writes, steps on scale, takes off belt, takes off shirt, takes off wedding ring, orders large pizza. We only order the large pizza when our weight is under a certain amount, but to get our weight under that certain amount, it's not that we're eating healthier or exercising more. We're playing with the scale. We're stepping on the scale with one foot, taking our wedding ring and our belt off. When something becomes a measure, it ceases to be, or I should say when something becomes a target, it ceases to be a good measure. The next thing the book talked about is mathiness. Who remembers the book talking about this? Who wants to remind us what mathiness is? So mathiness was, as the book referred to it, this idea that we can come up with sort of objective numbers, heavy quotes, heavy emphasis, or seemingly objective numbers by using math. We kind of did this in this class. We said, John Gregory Brown is 4 units of lazy. That's going to drop his test score down. What does 4 units of lazy mean? Doesn't mean anything. It's something we made up for the purposes of teaching about regression analysis. We see this sort of mathiness all the time. And this has implications for how we think about the world. Peyton, you mentioned marketing earlier. We see this sort of thing in marketing, not to pick on it as a field, but people listing, oh, well, the truth equation is reliability times accommodation times how much self-interest you have in the matter. But when we start to unpack these equations, because they're not real equations, they don't make much sense. Several reasons why, but one of the reasons is these things are measured without units, and the units don't align. So my question to you all is, how do we reconcile this idea that mathiness is bullshit? I think we can agree, at least to some degree, that this is bullshit, with our genuine questions about given data, how can we predict things? How can we determine causes and effects? The example I gave last week with John Gregory Brown is 4 units of lazy, and that's going to drop his test score down. My intention wasn't to bullshit you all. It was to talk about how we might model different ways in which, in this case, student-teacher ratio is related to test score. But looking at it through the lens of mathiness, it feels like bullshit. So how do we reconcile these two? Anyone have any thoughts? I don't have an answer. I'm genuinely curious. How do we reconcile our goal to rule out alternative explanations with the fact that doing so might be bullshit?
Using those others as the main aspect of shit, using more than just one.
I'm sorry, I didn't hear you.
I said, can you repeat it again, please?
Yeah, how do we reconcile this concept of mathiness being bullshit with our genuine goal to use data to rule out alternative explanations? Yeah, see that.
I think it just makes that more difficult to accomplish. So maybe there has to be more like seemingly or as objective as possible data and reasoning behind things to make it closer to the truth.
Yeah, certainly. So it definitely makes it more difficult. Maybe being more upfront with our data limitations helps. So though we don't have a measure of how lazy John Gregory Brown is, other than our made-up unit of 4, we might have a measure of his productivity, and we can infer laziness from that, how many pages of writing he got done last week. Yeah, Elizabeth.
I'm starting to think that when you try to assign numbers to data that is quantitative, like productivity or laziness or things like that bullshit is kind of just a spectrum, and you're trying to be on the less bullshitty side of it. But you can do you can say John Gregory Brown's productivity is measured by how many words he's written, but that doesn't necessarily compare well to someone else's level of productivity. So, I don't know, I guess you just kind of aim for you're going to have to accept it's going to be at least a little bit.
Right, excellent point. So maybe our goal isn't to eliminate bullshit, but to minimize it. You raise another really interesting point, which is try and use one well-defined variable. So instead of calling it productivity, call it words per minute or whatever. And 2, try and use, of those well-defined variables, ones that are more comparable. So, the example in the book about the truth equation, your measure of self-interest might not be that comparable to someone else's. But we can measure, say, conflict of interest, and again, poorly defined variable, but conflict of interest as measured in how much money you have in the thing you're talking about. Excellent point. Anyone else? How do we reconcile the fact that mathiness is bullshit with our desire to rule out alternative explanations? Right, so the last thing that the chapter talked about that I want to get to today is this concept of zombie statistics. Who remembers what a zombie statistic is? Yeah, Pat.
So it's super like broadly defined, and they give you a number that seems really impressive, but there's no context for the number itself.
Right, excellent point. I might phrase it a little differently, but I think we're on the same page, which is they're sort of like cliche statistics. People cite them all the time, but it's not always clear, like you said, the context behind these citations, or even what they mean or where they come from. The example the book uses is 50% of scientific papers go unread. No one knows where this number came from. Everyone cites it all the time, at least in the sciences. Everyone cites that 50% of scientific papers go unread. When you dig a little deeper, the original stat wasn't unread, it was uncited. Citations and reading are not the same thing. When you dig a little deeper than that, it's not uncited, it's uncited within the first 5 years of publication. Uncited and uncited within 5 years are a little different. When you dig a little deeper within that, it's not all scientific papers, it's scientific papers within this particular subset of the sciences, I forget which one. Already, it's becoming more of a zombie statistic. I can't remember the thing I read last night. We've talked all semester long about the need to dig deeper when it comes to these numbers. But in doing so, now we have a bunch of tools we can use. We have ways of ruling out alternative explanations that we were talking about earlier. So, can anyone here think of a zombie statistic? Can anyone think of something that they've been cited, sort of as a cliche way, that they don't know where that number comes from? And let's be fair here, you citing a stat doesn't necessarily mean it's a zombie statistic. But can anyone think of some cliche numbers that have been cited to you? So one that I was thinking of when I was reading about zombie stats last night, which I think is relevant to all of us here at Sweetbriar, is, do women make more or less money than men?
You say that women?
Do women make more or less money than men? Less. Does anyone know the number that gets thrown around? The number that I hear most often is 73 cents on the dollar. Do you guys want to make 73 cents on the dollar relative to your male counterparts? Now let's dig a little deeper. Is this a zombie statistic? Where does that number come from? Yeah, Elizabeth.
It's like, if I remember it correctly, there was like some studies that just compared like general household income, like men versus women, without taking into consideration like careers or like specific fields within the career, like a pediatrician versus a neurosurgeon.
Excellent point, yeah. So women, as is cited in this, it's not even a zombie statistic yet, but we have a cliche statistic that we are now unpacking as a data-driven class. Women make 73 cents on the dollar relative to men. Elizabeth raises an interesting problem with this statistic. This number comes from the fact that we just did a baseline comparison of men and women. You raised two interesting points. One, men and women, broadly speaking, and all caveats up front, but men and women typically have different careers. Two, within those careers, men and women typically have different career paths. No, this might be problematic in and of itself. But if our only goal at the end of the day is to compare dollars earned, then we want to compare dollars within career and dollars within career track to dollars within career track. So excellent point. What's the difference between a neurosurgeon and a family doctor? They're both doctors, but one might have a higher male presence. And this is important, right? Because if we want to do things that are societally important, like fight discrimination, like empower everyone, we should have the right, and to the beginning of the class, the most objective numbers to back it up. And certainly numbers can't be fully objective, but we need to be upfront about what our modeling assumptions are so we can back it up, fight it with good numbers. So we've already started to break that difference down a little bit. We need to compare career to career and career track to career track. What else do we need to do to make this number more comparable, less bullshit? What are some other, remember, it's our job to rule out alternative explanations. What are some other alternative explanations for this difference in wage rate? Career and career track are two important ones. Yeah, Lara. Yes, please. Absolutely, data source matters. One of the problems with the zombie statistic is that often the source isn't clear. So that example in the book about 50% of scientific papers go unread was written not in a scientific article, but in a commentary article in Smithsonian Magazine. And the source they were citing was from something else, which was from something else. One of the problems with zombie statistics is it's often often hard to find, got a little tongue-tied, often hard to find the original source. Yes, data source is very important. For this exercise, where we are trying to rule out alternative explanations for why our data might tell us that women make less money than men, again, all caveats aside, let's assume that we all have an accurate and agreed upon data source, but maybe we haven't ruled out all alternative explanations. Yeah. Okay, so maybe what's going on is there are specific industries, specific careers that are throwing our numbers off. This is kind of like what we were talking about earlier, where I'm going to throw off the average age of the room. Maybe the problem is not in the median earner compared to the median earner, but the superstar earner throwing the average off. Excellent point. Let's go back to colleges lying with bullshit earlier. The University of North Carolina loves to say the average earnings of their geography majors. Does anyone know why? Because Michael Jordan was a geography major at North Carolina. So there are excellent point about maybe athletes are throwing our averages off. What are some other alternative explanations for why we might see this observed difference in male earnings and female earnings?
That was taking into consideration things like hours worked. Women tend to value like work-life balance more than men do. So a man might work just unlimited hours a week, where a woman might say, I would actually rather just go home.
Excellent point. We need to take into account hours worked and perhaps job tenure more broadly. What else? Yeah. Right. Negotiation is a big part. So maybe there's not discrimination in the offer, but people asking more. And remind me of your name, I'm sorry. Excellent point. Yeah, Elizabeth. Yeah, or none. But But again, broadly speaking, we can think of a lot of different reasons why we might, at the end of the day, have a zombie statistic. And if we don't care about the number in and of itself, we care about this broad societal question. Is there discrimination in wages? Well, to answer that question, we can't just throw a zombie statistic up. We have to throw up worker tenure and certain types of averages and negotiation power and career and career track. Yeah, Cynthia.
I think it's also important to realize that some jobs where businesses do not have like the physical capabilities to handle it. I'm thinking of things like when you need a wall, like heavy equipment, or there's big giant bags of cement. Most women can't handle that. And that's not to say that they can't handle it at all. It's just it takes more to get to the point for them to handle it.
Certain point, we can lump that more broadly into career and career track, though, right? Excellent point, well taken. The idea is, even after we control for all these things, even after we rule out all these alternative explanations, there still might be a difference in earnings. Even after we control for whether or not you negotiated, and career track, and hours worked, and job tenure, and superstars in the field, and any other, there still might be this wage gap. But if we're trying to fight that wage gap, we need to fight it with accurate and as objective as possible numbers. We need to be upfront with our modeling assumptions, with our sampling assumptions, with our sample size, with our counts. And from there, once we're, Elizabeth, excellent point, we still have some bullshit built into that system, but once we're on the less bullshit end of the spectrum, then we can start to foment change. All right, questions so far? So what did you guys think of this chapter? What were your thoughts, impressions? Did anyone like this chapter? Did anyone dislike this chapter? Yeah.
I liked all the very beginning when we had all the quotes about all the things people say, like, show me the data, the raw numbers, all those things. And then, we proceed to explain how those are relatively useless a lot of time.
Yeah, I mean, the fact that we have this sort of instinctual feeling that the numbers are going to stop us from being bullshitted is really compelling, I think. And the fact that we still get bullshitted, even when there are numbers present, I think is kind of problematic and alarming. What about the rest of you? What do you guys think of this chapter? Peyton, what did you think of this chapter?
Personally, I like the beginning and obviously got the examples, and I'm not really much of a math person, like numbers person. Like the marketing aspect honestly caught my eye, but when a lot like the numbers and explanations were thrown at me, it kind of just all kind of jumbled in my brain some personally at the chapter. But I like the beginning when they talked about how a lot of companies, like they mentioned Google, Amazon, and like they already know what you want to know, they already know where you want to go, they already know what you want to buy. I thought that was really interesting concept.
Yeah, we'll talk about this at the end of the semester when we get to our big data lecture, but there's this, I think we can call it a zombie statistic, this idea of Target sent this woman an ad or a coupon for prenatal vitamins before she knew she was pregnant. And it's been cited in the marketing research and the data research as this triumph of big data. But I'm really curious what her buying patterns were that led Target to, and their ML algorithm to make that determination. What about the rest of you? Any thoughts about this chapter you want to share with the class? So let's move it on to what big lessons did you take away from this chapter? Certainly, we can think of numbers not being as objective as we had once thought as a big lesson. What else? What big lessons did you take away? Yeah, right. Right. Data are going to skew, and that skew might lead us astray. What else? What big lessons did you guys take away from this chapter? So I find the example of Goodhart's law to be very compelling. That when something becomes a target, it ceases to be a good measure. I think that's a good lesson to take away, particularly because we all have targets in our own lives that we're aiming for. You all have targets right now in terms of things like GPA, perhaps in terms of GRE or LSAT. Maybe that's not a good measure anymore. What are you going to do to raise your GPA? Ask for extra credit? Is that a good, compelling example of how you are as a student? Or is it a compelling example of your ability at finding ways to game the system? Goodhart's law, I think, is a very important lesson. Numbers are not as objective as they seem. Once something becomes a target, it ceases to be a good measure. Percentages can ameliorate as well as exacerbate bullshit. So like I said, it's a light class today. Not many of you here. Think we can call it a little early. What we're going to do on Wednesday is introduce our next identification strategy, difference in differences. And I think this is going to be a really fun lecture. So with that in mind, everyone go forth, have a safe and productive Monday. We'll regroup here on Wednesday.